Let us discuss case 2 of addition of vectors, that is parallelogram law. Now this law you might have used in physics, where they have stated that if any two adjacent sides of a parallelogram are added, then their resultant is the diagonal starting from their point of intersection. Okay, so if I name this as A, B, C, D, okay, so if quadrilateral ABCD is a parallelogram, then we can apply the parallelogram law as we can add the adjacent sides of the parallelogram, and the resultant of the addition will be the diagonal starting from the same point. Now, as we have seen in triangle law, that we think of triangle law whenever there is a chain. Now, let me explain when we should think of parallelogram law. For parallelogram law in a sum, okay, we check three conditions. Number one, okay, vectors which are added start from same point. So here I can see that the vectors are starting with point A. Okay. The second condition after that, the resultant must start from same point. Okay, so as you can see the question itself here, the answer is also starting with point A. Okay, and the number 3 is the vectors which are added must form parallelogram with resultant as diagonal. Okay, so if you see these three conditions getting satisfied, then in such sum we apply parallelogram law. Okay, to explain you in a better way, let me take an example. If A, B, C, D, E, F is a regular hexagon, then show that AB bar plus AC bar plus AD bar plus AE bar plus AF bar is equal to 3 times AD bar. Okay. Also, we prove that it is equal to 6 times AO bar, where O is center of hexagon. Okay. Now, let's start discussing the sum. In this sum, okay, you can clearly see that your all the vectors which are added starts with the common point A, and there is number one condition satisfied. Number two condition, the resultant also start with the same point. Okay, so here both the conditions of parallelogram law is satisfied. Now the third and the most important condition is the vectors which are added must construct a parallelogram. Okay, so in the solution what we do is, let me draw a regular hexagon. Now here the word regular means the length of all side is equal. Okay, here in the diagram it may not look like, but it's a regular hexagon. So let us say A, B, C, D, E and F. Now here let us focus on the required vectors. Now you can clearly see that let's start with the combination of AB and AC. So I show AB and AC. Now Now my first question is, can they form a parallelogram? You might say no, but yes, they can form parallelogram if I extend or if I draw sides parallel to this. I can see a parallelogram is constructed out of it, okay? But the resultant of this, that is the diagonal of this parallelogram, is not AD, because I want AD in the answer, okay? So here, this combination does not works, okay? So I repeat again, we can construct a parallelogram using AB and AC, but it is of no use because we want AD as the diagonal, okay? So now let's change the combination. Let's take the vector AB with AD itself, okay? Now obviously I will not take ABD as sides of the parallelogram because I want it as diagonal. So let's not go for AD also. Now let's take the third side. That is, let us take AE bar. Now, if I say, can you construct a parallelogram using AB and AE as the adjacent sides? If you see this nicely, I can construct it by joining side BD. Okay. So what you find here now, can I say quadrilateral ABDE is a parallelogram? Okay. Where your AB bar and AE bar are the adjacent sides. And who's the diagonal here? Is it not the diagonal is your AD? So can I say the answer to this would be AD bar. Result number 1. Okay. Likewise, let us take the second. I'm redrawing the diagram. Okay. So again, if I take A, B, C, D, E and F, now I have done with AB and AE. Now let's focus on to the next vector, that is AC bar. Now if you see here, is it not AC can construct a parallelogram with AF. Now to construct a parallelogram using those two sides, I should join DF. And here you can clearly see that the diagonals of the parallelogram is AD. So here, can I say quadrilateral ACDF is a parallelogram? And with that, can I say therefore AC bar plus AF bar is equal to AD bar? Result number 2. Now with these two results, I think we have done with it. Let's take LHS. We had AB plus AC plus AD plus AE plus AF. Okay. Now which combination we have decided? We have decided AB will go with AE. Okay. AD will remain as it is and AC bar will go with AF bar. Now here both the results are AD bar and AD bar. Okay. So what I get is AD bar plus AD bar plus AD bar. What I get is 3AD bar. Okay. So the first part is proved. Now what they want is O is the center of the hexagon. So if here I can write LHS equal to RHS. Okay. The first part is done. Now I say if O is center of hexagon, can I say then O will be midpoint of AD? Okay, so if you understand hexagon properly, is it not in hexagon? The center of hexagon is the midpoint of the longest diagonal. This is the longest diagonal and the center is this. Now, obviously, this divides a vector AD into two parts, AO and OD. Okay, so can I say AD bar is 2 times AO bar? Okay, the direction is same but the length is twice. Okay, so we can write since length AD is equal to 2 times length AO. Okay, I repeat, I'll write length AD is equal to 2 length AO. Also the direction is same. Okay, so because of that we can write this particular result, direction is same. Okay, so now let's take the result again. Okay, let us take the results again. We had AB plus AC plus AD plus AE plus AF is equal to, we had 3 AD bar. Now we just came to know that your AD is twice of AO bar. So what we got is 6 AO bar. That is where we are done with this particular question. So in and all, I repeat again, okay, what we found out was, in this sum, the vectors which we are adding, okay, starts with the same point, that is A. The resultant vector was also starting from the same point, that is A, and the combination of two vectors were forming parallelogram, and hence we can go for parallelogram law. Let me take one more example on this. AB and CD are two parallel chords of a circle. Full stop. LM is the diameter of the circle such that L is equidistant from L is equidistant from A and B. Okay, then show that LA bar plus LB bar plus LC bar plus LD bar is equal to 2 times LM bar. Okay, now let's start with this sum. In this question, okay, I want to add the vectors. So I repeat again, whenever we see addition of vectors, okay, we think of three laws. Number one is triangle law, number two is parallelogram law, number three is polygon law. We always start with triangle law, but in a sum, triangle law is applicable when we see a chain. Okay, in this complete sum, we do not see any chain. Okay, so let's not go for that. Now let's try, is it parallelogram law or not? Now there are three things to check in parallelogram. Number one, is it the vectors which we are adding start with the same point? Okay, so here you can see that all the vectors are starting with point L. Okay, so the first condition of parallelogram law is satisfied. So I'll mark this important. Now, the second condition says the answer or the resultant should also start with a common point. So yes, there you are. The resultant also start with point L. But the most important is the combination of vector in this, okay, should form a parallelogram. Okay, so anyone will form parallelogram with LM as diagonal, then I can go for parallelogram law. Okay, fine. So what we do here is, let us start with the diagram. So in solution, let us draw a circle. Now they are saying that there are two parallel chords, AB and CD. Now the most important part of the diagram is drawing LM. Okay, if you see, where should be LM? Ideally, when I did this at the very first time, I thought LM will be here. Okay, but this is not the LM what they are looking for, because they said this point L has to be equidistant from A and B, which is not. Okay, so what we do here is, LM is not like this. If you understand, your LM will be in such a way that it should be perpendicular to the chords. Okay, and if it is perpendicular to the chords, now you can clearly see that your LA and LB will be equal. The reason is, your this perpendicular is also the bisector of segment AB. Okay, so that is how we get LM. Now what you do first is, let's show the vectors first. So I show LA bar, then LC bar, then LB bar, and then LD bar. Now let's take the combination of vectors. If I take LA plus LB, okay, as one combination, okay, you can see that here your LA and LB can form a parallelogram. Okay, if I join to the center, okay, if you see, it's a parallelogram. Okay, but this I will not go, because in this case the resultant will be LO bar. and what I'm looking for is LM bar. Okay, so let's not go for this combination. Okay, so we'll not go for this combination. Now let's try the other combination like LA bar plus LC bar. Okay, now L and LC, again if you see, they can form a parallelogram here. Okay, but the resultant is not LM. I want resultant as LM, so this combination also fails. Okay, so let's do one thing. Let's change the combination again one more time. Okay, now let us take the combination LA bar plus LD bar. Now if you see LA and LD nicely, okay, it forms a parallelogram. Okay, now to show the parallelogram here, I need to do some construction, and that construction will be joining AM and MD. If you see now, okay, is it not, it forms a parallelogram. So can I say quadrilateral LAMD is a parallelogram? Okay, and if it's a parallelogram, can I say therefore LA bar plus LD bar, that is addition of two sides, will be equal to the diagonal, that is LM bar, and that is result number 1. Similarly, if I construct now the other combination, that is BM and CM, okay, if I join that, again you can see that the quadrilateral LCMB is also a parallelogram. And if it is a parallelogram, then again I can say that LB plus LC is equal to LM bar. Okay, so this is your result number 2. Can I say therefore, let's take LHS. Initially LHS was LA plus LB plus LC plus LD. Obviously LA will go with LD, so I'll just make a group of it, LA bar plus LD bar plus LB bar plus LC bar. This gave me LM bar. This is also LM bar. Can I say from 1 and 2? 1 and 2. And finally what we got is twice of LM bar. Okay, so that is how we apply parallelogram law in this. Okay, so this is where we come to an end of the concept of parallelogram law. Okay, I repeat again, when we go for parallelogram law concept, we need to just see here two things, three things. I repeat, the vector which we are added should start from the same point, resultant must be starting from the same point, and they should form a parallelogram. Okay,